A nuclear submarine is a submarine powered by a nuclear reactor. The performance advantages of nuclear submarines over conventional submarines are considerable. Nuclear propulsion, being completely independent of air, frees the submarine from the need to surface frequently, as is necessary for conventional submarines. The large amount of power generated by a nuclear reactor allows nuclear submarines to operate at high speed for long periods of time, and the long interval between refuelings grants a range virtually unlimited, making the only limits on voyage times being imposed by such factors as the need to restock food or other consumables. Current generations of nuclear submarines never need to be refueled throughout their 25-year lifespans. Conversely, the limited power stored in electric batteries means that even the most advanced conventional submarine can only remain submerged for a few days at slow speed, and only a few hours at top speed, though recent advances in air-independent propulsion have somewhat ameliorated this disadvantage. The high cost of nuclear technology means that relatively few of the world's military powers have fielded nuclear submarines. Radiation incidents have occurred within the Soviet submarines, including serious nuclear and radiation accidents, but American naval reactors, starting with the S-1W and iterations of designs, have operated without incidents since USS Nautilus launch in 1954. The idea for a nuclear-powered submarine was first proposed in the United States Navy by the Naval Research Laboratory's Ross Gun in 1939. Construction of the world's first nuclear-powered submarine was made possible by the successful development of a nuclear propulsion plant by a group of scientists and engineers at the Naval Reactors Branch of the Bureau of Ships and the Atomic Energy Commission. In July 1951, the U.S. Congress authorized construction of the first nuclear-powered submarine, Nautilus, under the leadership of Captain Hyman G. Rickover, U.S.N. The Westinghouse Corporation was assigned to build its reactor. After the submarine was completed at the Electric Boat Company, First Lady Mamie Eisenhower broke the traditional bottle of champagne on Nautilus bow, and the submarine was commissioned USS Nautilus on the 30th of September 1954. On the 17th of January 1955, she departed Groton, Connecticut, to begin sea trials. The submarine was 320 feet long and cost about $55 million. The Soviet Union soon followed the United States in developing nuclear-powered submarines in the 1950s. Stimulated by the U.S. development of Nautilus, Soviets began work on nuclear propulsion reactors in the early 1950s at the Institute of Physics and Power Engineering in Obninsk, under Anatoly P. Alexandrov, later to become head of the Kurchatov Institute. In 1956, the first Soviet propulsion reactor designed by his team began operational testing. Meanwhile, a design team under Vladimir N. Peregudov worked on the vessel that would house the reactor. After overcoming many obstacles, including steam generation problems, radiation leaks, and other difficulties, the first nuclear submarine based on these combined efforts, K-3 Leninsky Komsomol of the Project 627 Kit class, called a November-class submarine by NATO, entered service in the Soviet Navy in 1958. Nuclear power proved ideal for the propulsion of strategic ballistic missile submarines and were only a year behind the US with their first SSBN, ill-fated K-19 of Project 658, commissioned in November 1960. However, this class carried the same three-missile armament as the Golf's. The first Soviet SSBN with 16 missiles was the Project 667A, the first of which entered service in 1967, by which time the US had commissioned 41 SSBNs, nicknamed the 41 for Freedom. At the height of the Cold War, approximately 5 to 10 nuclear submarines were being commissioned from each of the 4 Soviet submarine yards. From the late 1950s through the end of 1997, the Soviet Union, and later Russia, built a total of 245 nuclear submarines, more than all other nations combined. Today, 6 countries deploy some form of nuclear-powered strategic submarines: the United States, Russia, France, the United Kingdom, China, and India. Several other countries including Argentina, Brazil and Australia have ongoing projects in different phases to build nuclear-powered submarines. In the United Kingdom, all former and current nuclear submarines of the British Royal Navy have been constructed in Barrow-in-Furness, where construction of nuclear submarines continues. Conqueror is the only nuclear-powered submarine ever to have engaged an enemy ship with torpedoes, sinking the cruiser Ara General Belgrano with 2 Mark 8 torpedoes during the 1982 Falklands War. The main difference between conventional submarines and nuclear submarines is the power generation system. Nuclear submarines employ nuclear reactors for this task. They either generate electricity that powers electric motors connected to